I'm going to talk about factoring polynomials. In particular, I'm going to talk about the strategy that we use when we're factoring the sum or difference of two cubes. Remember, when we're factoring, we're undoing a multiplication problem. So we're trying to find the factors that when you multiply them together will give you the particular polynomial in question. So let's start by doing this multiplication. We're going to multiply a plus b by a squared minus ab plus b squared. We distribute the a across, so we have a times a squared, a times the opposite of ab, and a times b squared. And next we're going to distribute the b across, and we would have a squared b the opposite of ab squared and b cubed. And when we combine, we see that some of the terms drop off and we're left with a cubed plus b cubed. And what that tells us is that if we were to factor a cubed plus b cubed, we would get these two factors. So let's write that out. We have a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And essentially we have a formula for factoring the sum of two cubes. There is a similar formula for factoring the difference of two cubes, and let me just jot it down here. A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. And let me point out how we will remember this. When we're factoring the sum or difference of two perfect cubes, notice the first factor is just the original problem with the cubes pulled off. So our a cubed plus b cubed gives us a plus b as the first factor. And with an a cubed minus b cubed, we have a minus b for the first factor. Now, when I'm factoring the sum or difference of cubes, after I have that first factor written, I just use that and remember the pattern in order to generate the second factor. This first term is the square of the first term in your binomial. The last term is the square of the second term in the binomial. And the middle term is the opposite of their product. So the product of these two terms is AB, change the sign and it's negative AB. And I said it in such a way that it's true for both of these. Now let me just give you a problem to try and we'll see how this works. So the directions will be factor, and we'll write x cubed plus 8. So our task is to factor x cubed plus 8. I hope you recognize 8 as a perfect cube. Let's just write it as x cubed plus 2 cubed. So as soon as I identify that I have two perfect cubes that are being added or subtracted, I know I can use this formula or this pattern to do the factorization. So my binomial is what I get when I just rip off the cubes. So I take those cubes off and I have x plus 2. And then I set up a bigger set of parentheses because I know I have a trinomial coming. This first term is this term squared. So here I have an x, so this becomes an x squared. This last term is the 2 squared. So that means we have a positive 4. And in the middle, we always have the opposite of their product. So we multiply these two together and we get 2x. Change the sign, that's a negative 2x. And we have it factored. Let's do another one. So the directions will be factor, and we'll just use y cubed minus 1,000 this time. I hope you recognize 1,000 as a perfect cube. It's 10 cubed. So let's write that as y, the expression is y cubed minus 10 cubed. And so as soon as I see that I have the sum or difference of two cubes, I know it's going to factor into a binomial and a trinomial. So the binomial is what I get when I just rip off the cubes. So I just have y minus 3. My trinomial will be the first term squared, the last term squared, and the opposite of their product. So y times negative 3 is negative 3y. Change the sign to positive, so I have a positive 3y right here, and it is factored. Now, one of the things that people sometimes forget is the signs. Often the mistakes people make are in the signs when they're doing the factoring. So let me mention an acronym that you see sometimes, and it is this. SOAP, sometimes called the SOAPy formula. And let me bring you back to the formula so that you can see what I'm talking about. Here are formulas that we use for the sum and difference of two cubes. And it's the signs that we need to take care with. And when you factor the sum or difference of two cubes, there are 3 signs that we'll take care with. Right here, this first one, this second one, and the third one. The first sign you write is always the same as the original. So that's what the S stands for. The second sign you write here is always the opposite of that. Notice here we have a plus and over here a minus. Here's a plus and there's a minus. So the second sign you write is the opposite. And then this third sign is positive in both cases, so we say it's always positive, and that's what this AP stands for, always positive. So I'm going to use that acronym when we factor our next problem. Get rid of this one. So here's our problem. We'll say the directions are factored completely. So we'll factor 2a cubed plus 54. You'll notice this time we don't have perfect cubes, but we do have a common factor, and we always take out common factors first. So for this particular problem, we have a common factor of 2. So let's take that out. And we have 2 times a cubed plus 27. Now we have the sum of 2 cubes. I hope you recognize 27 as 3 cubed. So I'm going to bring down my 2. Then I have my binomial and my trinomial. And now let's use our acronym for filling in the signs. The same sign, the opposite sign, always positive. And sometimes people just like to put those in and then they don't have to worry about the signs anymore. So in the binomial, I just rip off the cubes from my expression here. I have an a cubed, so I just write an a. And remember, 27 is 3 cubed, so I would just have a 3. And now I practice the pattern. The first term here is the first term squared. The last term here is the last term squared. And in the middle, I take their product. So 3 times A or 3A. And factoring the sum and difference of two cubes, it's really just a matter of practicing that pattern. Let's do one more. The directions will still be factor completely, and let's make this one be 8A cubed minus 125B cubed. Do you recognize these as perfect cubes? We can take this intermediate step to really point out the perfect cubes. You don't necessarily have to, but let me point out that 8A cubed is 2A in parentheses being cubed. Minus, and here we have 5B in parentheses being cubed. So when we use our pattern for the difference of two cubes, I know I have a binomial and a trinomial. The signs, back to our SOAPy formula, are the same, opposite, always positive. Now I don't have to think about those signs anymore. I rip off the cubes for the binomial that's first, so I have a 2A minus 5B. And for this first term of the trinomial, I square the 2A, so that's 2A times 2A, that's 4A squared. For the last term of the trinomial, I square the 5B. 5B times 5B is 25B squared. And in the middle, I will have their product. 2A times 5B is 10AB. And I'm going to point out that in each of these problems, the trinomial here was prime. That's why I didn't work to factor it any further. So now I hope you can practice factoring some sum and difference of two cubes.